Okay, Robbie, can you hear me?
Yes, I can.
Perfect. So let's start then. So hello everyone, happy LGC. This is great to be here and to be part of the LGC event again. For me, this is the third time that I can participate in this event as a host. My name is Jabil. I am a proud member of the Lean Enterprise Institute Hungary team. And I joined this event from Budapest, the capital of Hungary. Let me introduce you our speaker, Robert Ferenci, who is working as a work cell manager at Jabil Hungary. And he will talk about his improvement journey, his lean journey, about how he could minimize the number of possible errors during selective soldering process by using lean principles, by using the PDCA cycle, by experimenting and figuring out a solution and building it into the machine that can reduce the number of errors instead of buying and integrating a complex pellet return system into the line. Before I hand over the word to you, Robbie, just let me share with the participants some details about your professional background. You have already more than 20 years experience in the field of manufacturing and in the field of lean. Started to work as an engineer, and then later became a project manager of several projects, and then now you are working as a work cell manager. So it's a very interesting and insightful story you will share with us. Before you start, just one last comment from my side. If you have any questions, then please use the Q&A function of Zoom, and we will have 5 minutes at the end of the presentation to answer them. So, Robbie, the stage is yours.
Thank you, Csaba, for the introduction, and thank you for being here by the name of Jabil. And before I start, I would like to say a few words about the company for a better understanding of the background. I hope you can see my screen. So Jabil history is a traditional American dream. It has been founded in 1966 in the kitchen table and by James Gordon and Bill Moran. And for today, they've grown to a huge, more than 140,000 employees company all over the world with more than 100 facilities. The headquarters in Florida, St. Petersburg in North America, but they are in South America, Europe, and Asia as well. And let me say a few words about Tiszaújváros, because this site is the largest contracted manufacturer in Europe, and we are in the top 10 in the world under the Jabil umbrella. We built strong relationships with 3 universities within 70-kilometer range, and we are 5 hours from most European cities. Our capabilities. We've got design for sure manufacturing, test, automation, environment like clean room, quality lab, and innovation capabilities. Within manufacturing, SMT, automated, hybrid automated, soldering, press fit, screwing, and many more solutions available for production. We've got customers from automotive, industrial, telecommunication, and healthcare and consumer sectors as well. And we are committed to improve better and better solutions to serve our customers. So today, I would like to introduce one of our great projects from the thousands in Tiszaújváros. The purpose of this project is to use a different approach to build a selective soldering process. When a new automotive business introduced in Hungary, we faced several challenges. We took into account all of the circumstances, and we recognized the old way to use soldering pellets with extremely complicated method cannot be followed. We saw huge risk in it, and that is why we started to think on a simplest and therefore cost-effective soldering solution. What are these circumstances? No touch, no rework allowed in the production area. That means only the first pass product is the good product. The most critical is to reduce the occurrence of the errors from quality standpoint of view, pallet handling process is complex, manual, even on an automated way. Cycle time is defined in advance. Cleanliness requirements were not installed before in Tiszaújváros, and the optimized production area was a good opportunity for cost reduction. How we achieved? We had to step back and wait a minute. We wanted a stable and a sustainable solution. So we totally removed the solder pallet returning system and replaced with a built-in solution. Means only one piece pallet need what is part of the selective soldering machine like any other components. The result is exceeded all expectations. Zero failure, zero manual handling. The process is reversible. Furthermore, this project won the local and subregional lean delivery best practice competition, and least, but not last, we saved a lot of money. What you can see in the layout is a traditional way of the selective soldering production. What does it mean exactly? If the product design requires to keep the through-hole components on the board during the selective soldering process, a soldering pallet must be used. It means every single product must have a soldering pallet. And to be able to keep the production capacity, the whole production circle must be fed with pallets, means the board loader needs to be filled with products, with PCBAs. The robotic cells continuously must work. The return conveyor system with the lifts must be full of pallets. And the assembly machine, AOI, X-ray, selective soldering, and conveyors also must be filled with pallets. And furthermore, to replace and maintain the pallets, we need additional manual handling out of the production area. So clearly visible, several goals were not compliant with this solution. The most common and critical point here is the solder pallets itself. And the additional processes, what keep them in a good condition. Currently, the cleaning and maintenance is 100% manual, means visual inspection, component replacement if that is necessary, and all of these need to be done out of the clean production area. That causes additional handling and requires spare parts on stock for repair. 20 pieces pallets continuously need in good condition to keep the line capacity. Furthermore, the pallet can bend during the usage, and that can influence the quality of the soldering. The maximum allowed flatness is less than 100 micron here. I was a quality engineer before, and I have personal experience from other automotive businesses because the pallet is a nightmare when a soldering related root cause needs to be found. So the additional process means more risk, means high occurrence of failure, even more cost. So our question was how we can avoid the above mentioned circumstances and make our life much more easier. So that is why we had an idea how we can integrate the PCBA support into the selective soldering machine. Our contracted suppliers version did not meet our expectation, but one of them find a way to start to work with us to build the inner pallet idea into the selective soldering machine. After several meetings and negotiations, the final version of the inner pallet is realized, and let me describe how this works. With this solution, the following processes and/or machines became unnecessary. Previously, I removed the pallet storage area, but what is not necessary now? The board loader is also robotic cells, return conveyor system with lifts, and what has remained is a straight, simple solution where we do not need operator interaction, more than 80% of the potential failure source removed, production area reused, much more cost effective, and more effective from operational standpoint of view as well. So the traditional way of layout became a very simple line, and now only one pallet is built into the selective soldering machine instead of an external multi-pallet. Furthermore, all additional pallet handling and maintenance are not needed anymore. The revolution here is to keep everything under the same control in the selective soldering machine maintenance. But as you can see, we were still not on our goal. This solution was just the start. This was the point where we started to make the process perfect. The final inner pallets solution can be seen in the picture below, and it can be shown how it fits into the selective soldering machine. In all cases, 2 pieces per we need it because our machine has got 2 pieces of solder bus. As I mentioned, we have remained few findings to solve. The first was the cycle time. Based on the measurement, the current cycle time was 42% above the target. So we started to modify the process steps. The first part was easy because it's clearly visible the solder head movement in the solder bus was too long. After the change, we reduced 33% cycle time, but that was not enough yet. So here you can see, but this is an example, just here you can see what we made before and what we modified. This is the way how we saved time. We had to dig deeper because the last 9% was the hardest part of the problem. Only one factor change was not enough to reach the results. So the solution was to reduce the contact time between the solder head and the PCBA surface, in parallel, rebalance the work content between the solder bus. Additionally, the biggest and heaviest components was the priority during the soldering process, where more layers are in the PCB. Therefore, we were able to reduce the previous process step cycle time, the preheating, and that led us to the final cycle time reduction. So we were happy because one more obstacle overcome, but as you can see, this solution was not sustainable yet. So let me jump to the stabilization. This product was a prototype in this phase, and based on the customer feedback, we had to reduce further the flux residues on the board surface. But this reduction caused instability in the barrel fulfillment because less flux caused insufficient solder around the through-hole components legs. So you can see what was the result and what we had to achieve. So in this case, we took our link acknowledgement again and checked several potential root causes, and we found the solution in the component and chemical data sheets. The soldering temperature was barely above 145 degrees, and that temperature overburned the flux quantity and disappeared from the critical surfaces. So several heat profiles measured, and we found the right temperature level. So the heat profile modification and the previously mentioned rebalanced work content together gave the final solution. X-ray is the next step after the selective soldering, so we were able to check piece by piece the outcome of the modification. So as you can see now, we already stabilized the process and our capacity was enough, but one of the main parts is still missed, the cleanliness. Why did I say this? Because it has been clearly identified at the beginning of the project. Even we are perfect, all of the KPIs is 100%. Or if we have zero scrap, the cleanliness is a go, no-go criteria to turn the production to SOP phase. Before we even started to produce anything, we had to build our own cleanliness procedure. And to be able to understand where we are regarding the particles, the measuring method had to be identified. So the measuring method established, and now we can see the results of all actions, because to reach the level of the technical cleanliness requirements, several actions had to be done. Covered and separated production area, touchless production, change the employee mindset across several trainings and lead by example, cleanliness rules with clean workloads, and continuous measurement. And this quality control led us to find the last piece of the puzzle to reach all of our goals. Quality lab were able to identify the size and the origin of the metallic particles, and we found that the maintenance plan in the selective soldering had to be reviewed and modified. After the modification, since 8 months, we were able to keep the contamination under the limit. It means now we have a stabilized, sustainable, cost-effective selective soldering process with an innovative built-in pallet solution. What is the business impact here? So the first facility now is 100%. The scrap is zero. We launched several A3 projects to reach these results. Cleanliness requirement passed continuously and the customer is satisfied. But one of the most important things is that the manufacturing team is more than engaged because they received a well-made engineering solution to build products in a good quality. Just a well-defined maintenance need to be done by them. The future opportunities is other great part of the solution is the process is reversible. Why is that important? Imagine if a business has a wide product portfolio with 100 different kind of part numbers and uses selective soldering process, but does not want to invest into the project a lot of money at the same time, so they order only one piece of inner pallets, make a trial run, and if that is success, the rest of the pallet order and the trial production can be scheduled financially. But why? Because the changeover between the traditional and the new inner pallet is around 2 minutes or below. Because the inner pallet changeover is a plug-and-play solution, and does not necessarily any special tool for that. Based on the visit, what we had in the near past in Tiszaújváros, clearly visible, the cleanliness requirement became a base standard in the automotive industry. It can support to reduce the contamination on the production with a well-defined maintenance. As a conclusion, if we identify clearly at the beginning what is the purpose of the project, what are the critical points, and we use what we have learned from the lessons. Furthermore, we investigate the whole by lean perspective, we can build more from less. Thank you for your attention, and I'm waiting for the questions.
Okay, guys, now it is time for questions. We still have some time that we can use for asking question from Robbie. If you have any questions, then please use the Q&A function of Zoom. Until you figure out some questions, here I have some. This is an improvement journey with a lot of PDCA cycles, with a lot of learnings, problem solving, with some trials that were successful, with some other ones that were not that successful. So my question is, what was the biggest challenge you had to face during this improvement journey?
Based on this 15-20 minutes, it seems it was easy because we found a good way at the first time. But when we implemented the inner pallet solution, after it took 6 months to make the whole process perfect. One of the challenges was that this was a prototype production, and we had very low amount of quantity of components. And sometimes when we figure out something, when we found that is going to be the results, that is going to be the good way, we had only a few pieces products to produce. And when we turn to another production, it seems that solution is a dead end. So during this journey, we had a lot of dead ends, and as we were able to start to increase the produce quantity, that helped us to find what is the real good solution, and all of the root cause analysis, all of the engineering activities with the increased quantity together led us to find a real good way to make it perfect. And now we are producing. We are on an SOP phase in a mass production, and we produce much more quantity, and all of the activities what we had in the past is already we already can see a lot of evidences that all of them is working well.
Thank you. In the meantime, you got 3 questions, Robbie, from the audience. So thank you guys for asking questions. Is this assuming, I mean, is your solution assuming that there is only one kind of PCBA being processed in the selective soldier?
No, one kind of PCBA, but not one kind of product number. But if the question is how this can be, as I mentioned at the last slide, if the question is how this can be extended to other products, actually, this is what I mentioned over there, that the solution is a plug and play. So actually the inner pellets itself is just a piece of metal. And it just, you need to take it out. There is a piece of part what you have to plug it out, and after that it can be replaced. And it's very easy. And it's very low. The changeover is very limited. And in the previous solution, the old version, when you use a manual pallet handling, etc., this can be used in parallel as well. So if that is the aim of the question, that is the answer for that.
Okay. Second question, how long did it take to solve the problem?
I did join last year, September, and the final solution was finalized in February. So it took 6 months.
So that was the total lead time of this improvement.
Exactly.
6 months.
Exactly.
Okay. Next question. How do you ensure that lean principles remain relevant and adaptable in a rapidly changing global business environment? That's a quite general question, but let's think about it related to this project.
Is it possible to re-ask this or re-think this question? Because I do not really understand the aim of the question, or re-ask it, or change the way how you ask it.
So how can you ensure that lean principles are still applied? In your production?
Because in case of this production line, the selective soldering is just a small portion. So yes, the selective soldering procedure is solved. Is sustainable now based on the continuous measurement, and we can see day by day the results of it. But this is not the only. Furthermore, our company, our company has got our own lean department, and everybody in the company is learning about the lean, and we are approaching all of our problems across the lean acknowledgement, because everybody knows the base acknowledgement of the lean. So we use what we learned.
Great. So you will start new PDCA cycles, and you will further improve. Maybe also this concrete solution, right? I mean, this could be a kind of reframing of the question. How can you ensure continuous PDCA? How can you further improve this concrete solution that you have just introduced?
Improve further. It's a pretty good question, because based on the results, what we can see is the solution is totally automatized now. So do not need human resource. It can deliver continuously 100% good products. The only what we have to keep continuously in a good condition is the maintenance. And the next step, because the the team who is working with these machines is permanent. And the next step can be, if I change the production team and the technicians, how I can give this knowledge further to keep the same quality in the maintenance and in the production. And that can be a next challenge here, because currently there is no fluctuation in our business.
Great, thank you. We have two more questions. I mean, we only have time for two more questions.
Okay.
The next one is, in terms of loading and unloading, is the part now in direct contact
No.
with the
No.
conveyor as opposed to being on the pallet? Does this drive and leads to any quality issues? That's the
No,
question.
because there is no any manual interaction. So the product is loading by machines to the beginning of the line from the previous SMT production, and it's totally automatized, and there is no any human interaction during the production. The whole line is totally automatized. That's why when the boards arriving into the selective soldering machines, inside the machine, the down and upper pallets just closing together, keep the components on the right position during the soldering process, open and lead the boards further. And every single time, just the board moving automatically, and the pallets is keeping on the same level every single time. And now the pallets is part of the selective soldering machine, as I mentioned. And in that case, it's part of the daily maintenance. So, and this is the way how we can keep it clean. This is the way how we can keep the production clean. If that was the aim of the question.
Okay. Next one. We only have time for one last question. Did you need to implement additional actions to reduce the metallic particles, or just tougher preventive maintenance was enough?
That was the when everything has been solved, and the barrel fulfillment was perfect. There was no any issue in the production line. We did not produce scrap. The yield was 100%. During the continuous quality control, we found that the product still can be contaminated by metallic particles. And as we identified step by step what is the main point in the maintenance, it disappeared. It's totally disappeared. So as I mentioned, since 8 months, there is no failed measurement in the quality lab. Even every second week has to be measured, and every month a final product has to be measured.
Okay, great. Thank you. Thank you for answering this question. Now time is up. We only had so much time in this time frame for this presentation. Robbie, really thank you. It was a really insightful and really powerful story about how to improve a line in a soldering environment. So thank you very much. And I just would like to encourage the other all the attendees to not to leave AGC, but to listen to the following presentations. We have 24 hours, very strong and really insightful content. So thank you, guys. Bye.
Thank you for listening to me. Bye.